Embeddings are the backbone of modern natural language processing, particularly in large language models. They represent words, phrases, and even documents as numerical vectors, allowing for efficient computation and analysis. So today we will understand different types of embeddings, be it a word, contextual, sentence, document, and cross-model embedding. So let's get started with this word embeddings first. Now these word embeddings are a way to represent words as a numerical vector. And these vectors capture the meaning and relation between the words in a way that computers can understand and process. So imagine you have a set of fruit names like apple, banana, orange, and grape. Now this word embeddings represent each of these words as a set of numbers or a vector. So if the embeddings are done well, the numbers for apple and banana will be closer to each other than to the orange and the grape, because apples and bananas are more similar fruits than apples and oranges. And this helps the model understand the relation between the words and enable it to perform various tasks like translation, classification, and language generation more efficiently. Next comes the contextual embedding. Now, these contextual embeddings are a way to represent words differently based on the context they appear in. This means that same word can have different meanings depending on the sentence it is used in. For example, the word bank can refer to a financial institution when used in the context of I need to visit the bank. But it refers to the side of a river when used in I prefer to go jogging by the bank of the river. Now, this contextual embeddings allow language models to understand this nuance by adjusting how well they represent words in different contexts. And this helps the model make more accurate predictions and provide better responses when generating text or answering questions. For example, consider the word bank in the sentence I need to visit the bank today. So in this context, a model with contextual embedding might represent bank as a vector close to the words like account, deposits, and loans. In contrast, in the sentence, I enjoy spending time by the river bank. Now the same word bank might be represented by the vector close to the vectors like river, shore, and water. Next comes the sentence embeddings. Now these sentence embeddings are a way to represent an entire sentence as a single vector that captures its meaning. And this allows models to understand the overall sentiment, context, and relation between the sentences. For instance, imagine you have two sentences. I had a great time at the party. And the second sentence is the food at the restaurant was terrible. Now these two sentences can be represented as two different vectors that capture their distinct meanings. So when comparing these two sentences of this embeddings, the model can easily tell that they have opposite sentiment. One is positive, other is negative. And this information is crucial for tasks like sentiment analysis, where the model needs to determine if a given text is expressing a positive, negative, or a neutral sentiment. Next comes the document embeddings. Now, this document embeddings are a way to represent an entire document, like a blog post, news article, or a book chapter, as a single vector that captures its meaning. And this allows the models to understand the overall content, structure, and relations between the document. So imagine you have two school essays written by two different students about their favorite hobbies. Now this document embedding helps represent each essay as a single vector that captures its content, structure, and style. And by comparing these two vectors, a model can tell if the essays are similar in terms of their content. Example, both talk about hobbies, and the style, that is both use similar vocabulary and sentence structure. And this information is useful for tasks like identifying the author of text based on their writing style, or categorizing essays into different categories based on their topics. And next comes cross-model embeddings. Now this cross-model embeddings refers to combining the output of different language models to create a more comprehensive understanding of a piece of text. So this is like asking multiple experts in different fields to share their insight on a topic and combining their perspective to get a more robust understanding. So imagine you have two models, model A and model B, which both can turn word into the colorful shapes, that is the vectors. So this cross model embedding lets you compare the shapes generated by model A with the shape generated by model B, even though they might be different. For example, both models might represent the word apple as a green triangle by the model A, and the model B says this word apple as a yellow square. Now this cross model embedding allow you to compare these two shapes, that is the green triangle from model A and the yellow square from model C, to see how similar they are. And this helps you understand how similar the model thinks the word apple is across different models. Thank you.